Volume. So what really is volume? It's a word we hear all the time, but in math it has a special meaning. Just as we think about it in everyday life, volume is a measure of space. 3D space to be precise. So let's say I have a balloon, like this one right here. It's not inflated right now, it's pretty flat. Not actually just two-dimensional, but there's no air inside of it right now to puff it up. So right now it's not really taking up very much space. However, when you inflate a balloon, you increase its volume because it takes up more space. The volume of a balloon is hard to calculate mathematically. The volume of a box is pretty easy though. Let's take this box for instance. We can see that there are 3 different lengths that we can talk about with this box. If I tilt it a little bit, you can see its height, this length right here. You can also see the width, which I'm going to call this dimension, and we can look at the length too, right here. Since this is kind of bulky to work with right now, I'm going to draw my own rendition on the tablet. So here is my very fancy drawing of a box. You can see I've labeled the length, the width, and the height of the box, the 3 different measurements that we can take of it with a ruler. Now for a box, the equation to find the volume is quite simple. The volume is just equal to the length times the width times the height. In fact, I'm going to go ahead and label these sides with these abbreviations. So here we go, one side length of L, one of W, and one of H.